guys. So I'm sorry that I have to do this, that I have to go through and do a few slides via this recording. It is definitely not what I had in mind for the start of this year, but I did not also think that I was going to be out this early in the year. So with that, instead of giving you guys some sort of, kind of mindless sort of task, I'd rather just get through a few notes if possible. This is where we left off. So if you need this material, by all means, go ahead and stop it here, pause it if you need to, and get this down. But we're going to continue on. We're going to talk about, we talked about environmental services, environmental indicators, and we're going to describe several environmental indicators. I think we're going to go through 5. I don't think we're going to hit 5 in this recording. I'd like to do 3 possibly, two for sure, definitely, but hopefully maybe 3. But again, they, just to define what they are, used to describe these indicators are used to describe the health and quality of a natural system, and it helps us analyze the health of the planet. So let me give you some examples of those. Number 1 is going to be biodiversity. That is the diversity of life within an environment. This can be broken down further into one of these 3 subsections, which is genetic diversity, species diversity, and ecosystem diversity. Genetic diversity, of course, is the diversity of one's DNA. Species diversity is basically defined as species richness or evenness, which we'll discuss later on. And then ecosystem diversity is the habitat diversity by area. Speciation, just as a reminder here, is the making of new species. On average, we discover 1 to 3 new species per year. The background extinction rate, however, is far greater. There's about 1 species per million per year that are going extinct. And that is where we kind of look at our own involvement and we think about that big critical question that I talked about. Are we harming the environment in a detrimental way, in a way that is hard to come back from? Scientists estimate that more than 10,000 species are currently going extinct each year. So if you break down, if you looked at it earlier, 1 species per million, that's the equivalent of roughly 10,000 species a year. Now, it's not all doom and gloom. Of course, we are responsible for the vast majority of this due to one factor, more so than any other, which is habitat destruction. But we've also been able to bring some of them back. We do negatively impact, of course, species diversity. However, we do have some programs that have been incredibly successful in bringing the species back, basically returning these species to their former numbers, including the American bison, the peregrine falcon, snow leopards, and the manatee, just to name a few. So I'm going to come back to math. We'll do that together. Obviously, I can't do that via a recording. But let's talk about food production. Okay, another indicator of how we are essentially doing, an environmental indicator of how we're doing as a species and how we are impacting the planet, is through our own food production. This is the ability to grow food and nourish the human population. Here's the problem with that. The human population has been growing steadily since the Industrial Revolution. So we are considered now a post-modernized civilization, and as a result of that, fortunately for us, most of our numbers have leveled off. We are not in the rapid growth phase that we were in the 1950s and the early 1900s. And fortunately, because of our large amount of land and our kind of engineering prowess, we've been able to engineer, fertilize, and basically just think our way out of most of these problems of feeding more people than we were able to before. I'm speaking of the United States in particular here. However, when we take a step back and we look at the global influence of food production, it is becoming harder and harder, even with our advanced technology. It is becoming harder and harder to feed the now 8.2, I want to say, billion people on the planet. So that's a huge amount of mouths to feed. And worldwide production of grain per person, also called per capita, has leveled off in recent years. It is not at all keeping up with population growth. So this is that per capita grain production. And you can see that obviously there's lots of ups and downs. But over the course of the last several, probably since the 1970s, we really haven't seen much growth. We've hovered in that 300 to 350 kilograms per individual. In fact, right now there's currently a downward trend. since 1985. So I would argue that that's a little bit of a misconception because we do see an upward trend here. So I think we're still doing okay. The other average, or the other indicator that we pay close attention to, and one that we're going to talk about at length in this class, is the average surface temperatures on the globe and how they correlate with carbon dioxide concentrations. So greenhouse gas, the greenhouse gas carbon dioxide is probably the most prevalent. It's the one that's the most well known. It's the one that is arguably the most devastating to the Earth. There are other more potent greenhouse gases. However, this one stays around forever. And over the last 2 centuries, we have just added to it and added to it and added to it. To the current 421, I say current, I'm sorry, I should have looked this up, but I will momentarily. Hold on, let me look here real quick. I don't think we're at 421. I bet you we're at 422. CO2 concentrate, atmospheric CO2 concentrations. So, oh, currently, wow. And, well, again, it depends on the source. But the first number that I'm seeing is 419.1, which would actually be lower than the concentration that I looked up last year at 421 parts per million. Still, an increase all the same over the last 2 centuries. It's interesting that there's a slight variation there. Now, what is causing that increase? That becomes this central kind of aspect of this. We know that carbon dioxide, we've proven since the 1950s that carbon dioxide does, accumulation of carbon dioxide within the atmosphere does cause an increase in the greenhouse effect. But are we the ones causing that, or is that just part of a natural cycle, a natural ebb and flow, the cyclical nature of the composition of gas within our atmosphere? Is this caused by anthropogenic causes? Basically, are we causing it? It's derived by human activities. And that's a question that we're going to try to answer later on. But for a little refresher, this is a nice little model, a nice little picture that kind of explains how greenhouse gas works. So greenhouse gas, the best way that it's ever been described to me, acts as a blanket around the Earth. The more greenhouse gas we have, the thicker the blanket. And as solar radiation comes in through the greenhouse gas, because it is transparent, it hits the Earth, it becomes thermal energy, so it actually changes from just solar radiation to thermal radiation. It comes off the Earth with that thermal in that thermal form, and it hits that atmosphere, and it can no longer escape it. Okay, even though and guys, you've experienced this, by the way. Sunlight comes in through the glass of your windshield, right, and then it hits the interior of your car. That changes it to thermal energy. And because of that, it can no longer escape your car, and your car just heats up and heats up and heats up. If you have a black interior and you let it sit in the sun on a 90-degree day or a 100-degree day, you can't even touch the steering wheel. It becomes so hot. So your car is essentially mimicking a greenhouse gas. The windshield is the gas, essentially. So hopefully that helps make sense of it a little bit. And I'm going to continue on here. I don't know if we're going to get to human population. I think I'm going to stop there. But I do want to show you this graph. This is CO2 in parts per million. This graph only goes to the early 2000s, possibly mid-2000s. So it doesn't go as far as I'd like, but it does show a distinct correlation of the CO2 concentration, which is that blue line kind of going up. You guys can see it there. Laid alongside the global temperature. And you guys can see that there is a distinct correlation between both of those. They are directly correlated, meaning when one goes up, the other one also goes up. It follows it. So as the CO2 concentration goes up, so does our global temperature. Now, here's one of the things that I want to stop, though, in our kind of mindset with this. Causation. okay, and correlation are different things. So just because something is correlated doesn't mean that it is the cause. Now, I'm not arguing for or against global temperature or global climate change as of right now. We will talk about it at length when we get to chapter 19. However, I do want to stop. I mean, don't get me wrong. I'm not denying it either. It's definitely up for discussion, and it's something that I happen to agree with. But I do want to caution you. Like I said, never look at correlation and believe that it is causation, because those are two distinctly different things. And I'll give you guys some examples of that next time I'm here. So I wanted to keep this at about 10 minutes. We're right there right now, guys. So thank you. We'll stop there. Whatever other time you guys have will be yours. See you guys on Thursday.